Good afternoon, student. Can you hear me?
Yes, sir.
Okay. In this lecture, we are going to discuss about the multiplexer and demultiplexer. As we know, combinational circuit and sequential circuit. These are the two basic circuit in the here digital system design. Combinational circuit are those in which the output of the circuit it depends on the instant value or present values of input. Otherwise, sequential circuits are those in which the output of the circuit it depends on instant value as well as some past previous input output. When we see the examples of the combinational circuit, as we discussed already about the adders, half adder, full adder, when we add two bits, two binary bits, A and B, if suppose the variable 0 plus 0, 0, 0 plus 1, 1, 1 plus 0, 1, 1 plus 1. Here, sum is 0 and carry is 1. As we know, this is half adder, design of the half adder. Then by using key map, sum and carry. Here, sum which is equal to ax or b, and carry which is equal to a and b. Also for the full adder, we have calculated already in the previous lecture. What about the truth table? What about the K-map pattern? What is the logic design? Uh, Here for the full adder, when we add three bits, A, B, C in, then what about the sum and carry? And when we consider the here half subtractor, then we have to subtract the two bits. When we consider the full subtractor, then we have to subtract the three bits. These are all combinational circuit. The adders, subtractors, multiplexer, demultiplexer, decoders, encoders, all code converters, binary to gray, gray to binary, here binary to XS3, all code converters, binary to BCD, BCD to XS3. All these are the code converters which are used, which are known as combinational circuit. Means the output it depends on instant values of input. That is said to be combinational circuit. Then what about the multiplexer? Multiplexer, it is one of the combinational circuit in which we can consider multiplexer means many into one. A multiplexer has many inputs and only one output, so that it is called as many into one multiplexer. It is one of the combinational circuit, means it does not require any memory element. Whatever instantly presently given input, based on that output depends. So that when we consider the multiplexer, a multiplexer is the combinational logic component that has several input and only one output. It has many inputs and only one output. It has also select lines. By using the select lines, it selects here from many input only one output. Here from many inputs it select only one output by considering the select lines. So that when we consider the here select lines, it is the important part when we consider here two select lines, then possible inputs are four and only one selected in the output. If only one select line 2 raised to 1, two inputs are there. Therefore, it is called a design of 2 raised to 1 mux. If we consider here two select lines 2 raised to 2, here uh, four inputs are there and only one output. If three select lines, eight inputs are there and only one output. 8 is to 1 works. For that, three select lines. If suppose four select lines, then 16 inputs are there, and from the 16 inputs, with the help of select lines, only one considered in the output. That is said to be multiplexer. Uh, See here, multiplexer contains the following: 2 raised to n data inputs. N is the selection input, means select lines. or select input, it is called as select input or select lines. From with the help of select lines here from the main input, here we can consider one of the from main input one of the output. A single output. Okay, multiplexer has single output. Selection input determines the input that should be connected to the output. The multiplexer, sometimes called as data selector, it is also called a data selector circuit. Uh, for the combinational circuit, when we want to select the data means from many input, if we want particular here input in the output, then here it is selected with the help of select lines, so that with the help of select lines we can consider as here only one output from main input. See here now, a multiplexer may have an enable input to control the operation of the unit. See here now about the 4 is to 1 mux, 4 to 1 multiplexer, or there are different types of multiplexer like that. 2 is to 1, 4 is to 1, then 8 is to 1, then 16 is to 1, 32 is to 1. These are the different multiplexers. 2 is to 1, two inputs are there, only one output is there. If suppose 4 is to 1 mux, four inputs are there, only one output is there. Then if suppose 8 is to 1 mux, eight inputs are there, only one output, and three select lines. Okay, for 8 is to 1 mux. For here 16 is to 1 mux, there are four select lines and 16 inputs and only one output. See here, when we consider 4 to 1 multiplexer, four data inputs are there for the mux. In short, multiplexer called as mux and demultiplexer called as demux. Keep in the mind, mux that is 4 is to 1 mux. It is also called 4 is to 1 mux or 4 to 1 multiplexer. For the four inputs, therefore only two select lines, because 2 raised to 2, which is equal to 4. Therefore, if suppose m are the select lines, n are the number of inputs, then we can say that 2 raised to m, which is equal to n. This is the formula. 2 raised to select lines, which is equal to number of inputs applied to the multiplexer. Okay, 4 is to 1 mux, 4 to 1 multiplexer, 4 data inputs. Then S0 and S1, these are the select lines. If we consider P1, P2, P3, here P0, P1, P2, P3, if we consider these are the inputs, then F is the single output. If we consider all the parameters, then we have to here draw a truth table. Select lines S0, S1, two select lines, therefore four possible combination: 0, 0, 0, 1, 1, 0, 1, 1. That is S0, 0, 1, 0, 1, S1, 0, 0, 1, 1, and output F P0, P1, P2, P3. These are the here output, selected output. If how it is, see here this diagram shows 4 is to 1 mux. Here four inputs are there: p0, p1, p2, p3. These are the inputs, and two select lines h0, s1. These are the select lines we consider for the multiplexer. 2 raised to 2, which is equal to 4, and only one output, that is said to be f. It is the output. When we consider this is the one of the multiplexer, then here if suppose s1, s0 and s1, if suppose 0, 0, then P0 it is created in the output. Okay, F which is equal to P0 means P0 it is selected in the output. If suppose 0, 1, S1 which is equal to 0, S0 which is equal to 1, then we can consider as P1 it is considered in the output. Then if S1 which is equal to 1, S0 which is equal to 0, then P2 which is selected in the output, and at 1, 1, because this is the binary for 0, 0, 1 binary for 1, here 1, 0, 2, and 1, 1, 3. Therefore, if suppose select line 0, 0, then P0 selected in the output. If select line 0, 1, P1 selected in the output. From main input, only one selected in the output, and it depends on select lines which are applied. Okay, if S0 and S1 which is equal to 1 1, then we can say that here P3 which is created in the output. If we consider the boolean function, boolean logic by using this truth table, then only one here output, uh, and it is selected from here different input, we can consider it as f which is equal to if suppose s1 bar s0 bar, because of this 0 0, then p0 f selected as p0, or therefore plus sign, or s1 bar s0 P1, or okay, this here F selected with the help of select lines. If suppose firstly the 0 0 S1 S0 which is equal to 0 0 S1 bar S0 bar P0, S1 bar S0 P1, then S1 S0 bar P2, or S1 S0 then P3. That is, OR operation is there. First expression, second expression, third expression, fourth expression, word 4 with the because of select lines. If select lines is 0 S1 0 0, then P0 it is created in the output. Then S1 mm, which is equal to 0, S0 which is equal to 1, then P1 created in the output. Means from the with the help of select lines, here if suppose 0 0 P0, it is created in the output with the help of select lines. With the values of select lines here from main input, only one selected in the output, and here by logic expression, with the help of logic expression, how it is determined, how it is considered, f which is equal to s1 bar h0 bar p0 plus s1 bar h0 p1. Means if suppose h0 s1 0 0 p0, s0 is 1, s1 is 0, then p1 selected in the output. Like that, if suppose s1 s2 these are 1 1, then p3 which is created in the output, it is called as data selector. With the help of select line, only one input it is selected in the output, therefore it is also called as data selector circuit, that is multiplexer. This is the design for the multiplexer. Then we can implement this by using logic gates. See here how we can implement this logic expression. We can consider S1, its bar S1 bar, H0, its bar H0 bar. Then here this F which is equal to S1 bar H0 bar P0 plus S1 bar H0 P1. Therefore, for that AND gate required, for that again the second AND required, third AND required, fourth AND required, and to combine all these because of this plus OR operation, therefore OR gate required. Therefore H0 bar S1 bar P0, this is S1 bar, so S1 bar H0 bar, see here the connections for the first and P0, it is considered as this. Then S1 bar H0 P1, S1 bar H0 P1. This is the input of OR gate, and output is S1 bar H0 P1. These are the S1 H0 bar P2. These are the input for this. Okay, P0 P1. Therefore, in the next S1 S2 P3, like that S1 S0 and P3. These are the, then after these are the logic, that is for the and first and second and third, the output and input for the four ands. And here in the OR operation, we can here consider one of the OR gate, and this F. This is the implementation by using logic gate for the 4 to 1 mux. In this way, here two inverters are required, four AND gates are required, and one OR gate is required. In this way, we can design here 2 to 1 mux. 4 is to 1 mux, sorry, to 4 is to 1 mux. Also we can design here 2 is to 1 mux, only one select lines. So make first of all truth table, consider h0 is the select line, s1 s is the select line 0 and 1, therefore I0 or p0 p1 it is to be considered. Then s S bar P0 and S1, uh, that is yes P1. These are in the OR operation. Two AND gates required and one OR gate is required when we design into S to 1 mux. Here 4 S to 1 mux. In this way, first of all, uh, draw is first of all write down 4 is to 1 mux. How many inputs? 4 inputs are there. How many select lines? Two select lines are there. Why two select lines? Because here 2 is to yum, which is equal to n. N are the number of inputs. 4 is to 1 mix. 1 mux means 4 inputs. Therefore 2 raised to yum, which is equal to 4. Therefore yum, which is equal to 2. 2 raised to 2, which is equal to 4. In this way, we can calculate the number of inputs and number of select lines for the 4 is to 1 multiplexer and only one output. Then draw is to table like that, to table S0, S1 and the output F. Therefore, make here data selector circuit, select lines H0, S1, P0, P1, P2, P3 from the main inputs, only one selected in the output. It is called as multiplexer. Any doubt, student? This is the implementation of the multiplexer. Okay. Any doubt in that? Is it visible?
Yes, sir.
Any doubt? Yes, student. What is mean by multiplexer? Multiplexer is a one of the combinational circuit from main inputs. Here in the output only one selected with the help of select lines. It is called as multiplexer. Okay, सब लोग है? Okay. Mishra, in this way we can consider the design uh, for the 4 is to 1 mux. Here from main inputs only one selected in the output. Just like that, we can consider also 8 is to 1 mux for how to straight is to 1 mux design. Here, consider again truth table. First of all, 8 inputs are there. Therefore, 2 is to yum, which is equal to 8. 2 raised to 3, which is equal to 8. Therefore, number of select lines are 3. Therefore, consider S0, S1, S2, consider the truth table, and P0, P1, P2, P3 up to P7. We consider if suppose S0, S1, S3, which are 0, 0, 0, then P0, which is selected in the output. Like that, we have to implement same just like that. 4 is to 1 marks. How we can implement this? Just like that, here we can implement, that is 8 is to 1 marks. How to construct 8 is to 1 marks from 2 4 is to 1 marks? This is the here one of the problem. X1 and X2 are the two output lines of 2 4 is to 1 marks. As X1 and X2, these are considered as output lines of 2 4 is to 1 marks. See here X1, X2. This is the logic of the 4 is to 1 marks. If suppose H0, S1, 0, 0, P0 it is selected in the output, H0, S1 is 0, 1, P1 selected, 1, 0. P2 selected in the output, here 1 1 P3 selected in the output. Just like that, X2 and X1, these are the two outputs which are considered for 2 4 is to 1 mux. This is the first X1 and this is the second. So that how we can implement first of all this by using logic gate or this by using logic gate and combine together with the help of OR gate. See here, when we consider the 0 1, here the S0 is 0 and S1 which is 1, then here we considered as P1 in the output, like that 0 1. If suppose we consider, then we also consider here 1, it is P1, it is in the output. See here x1 x2, we can consider this is for 2 here multiplexer x1 and x2. For x1 and x2, here we consider if suppose s1 s1 bar and s0 bar, here s0 is 0, means s0 is 0 and s1 is 1, then p2 which is selected like that. We can consider first and second, here this x1 and this x2 for multiplexer first, for multiplexer second, and for multiplexer third. We considered as s2, that is third select lines, because three select lines which are required to implement 8 is to 1 mux. Therefore, here S2 1 0, then F which is equal to S2 bar x1 plus S2 x2, that is said to be third select line. See here how we can implement it by using simple two multiplexers, that is all 4 is to 1 mux. These 4 is to 1 mux, these four inputs for the first, these two select lines for the first multiplexer, these two same select lines for the second, and these four inputs for the second, that is P0 P1 P2 P3 P4 P5 P6 P7. These are the number of inputs. So this here 4, here 4, here 2, these are the commons. Inputs are 8 and 2 select lines. So we require 3 select lines, so that for the multiplexer third select input it is to be considered, and this terminal and this terminal which are joined together, here we can take 0 0 0 1 1 0 1 1, no problem. So these are combined together and we can consider the output of the multiplexer. Then 0 0 1 0, if suppose 0 0 0 0 0, this 0 0, here 0, if suppose we consider select inputs 0 0 0, then p0 it is created in the output, just like that. Here we have to consider the when we consider 2 as to 1 mux, here 8 as to 1 mux, by using 2 4 is to 1 mux design. In this way we can implement the multiplexer design. Okay, this is the connection diagram, how here we can implement the here multiplexer. This is here 16 pins are there, and that is 1 2 3 4 5. This is one of the IC, 16 pin IC 74151. This is used for this 8 is to 1 multiplexer. By using IC also we can implement. See here where the inputs which are connected, where the plus VCC supply which are connected, here which terminal is ground, 8 pin number 8 and pin number 16. 8 is ground and 16 is connected to VCC. And then I0, I1, I2, I3, these are considered as 4 3 2 1 pins. Then here O is 5 6, O bar, here the enable 7, and like that S2 S1 S0 S1 S2. 11, 10, and 9. These are the connections, and here another four inputs are I4, I5, I6, I7, that is 15, 14, 13, 12. These are the here inputs. So in total, 8 inputs are there: I0, I1, I2, I3, I4, I5, I6, I7. These are the 8 inputs here, and the outputs is pin number 5. So here output bar pin number 6. This is the enable bar pin number 7, and the select lines 9, 10, 11. These are the S0, S1, S2. These are the select lines. This is the specification for the IC. These are the number of pins, which are the IC 16 pin IC, which is used for the implementation of here 8 is to 1 max. It is just like that. H0, S1, S2. These are the select lines. I0, I1, I2, I3, I4, I5, I6, I7. These are the number of inputs. Enable, it is said to be stroke, which are used to cascade other multiplexer. O, that is the output from the, if suppose 0 0 0, I0 selected in the output, 0 0 1, I1 selected in the output, 0 1 0, I2 selected in the output, 1 1 1, these are the select lines, then I7 selected in the output, and it depends on the select lines which are applied. Okay, this is the IC configuration for 74151. This type of IC, it is used for 8 is to 1 mux and the pin configuration. In this way, we can also implement here 16 is to 1 mux, then 32 is to 1 mux. Here also, here if suppose we will discuss in the next lecture, like if suppose the logic given for 16 is to 1 mux, then how we can implement by using 8 is to 1 mux. If logic given of 8 is to 1 mux, then how we can implement by using 4 is to 1 mux. Okay, we will discuss in the next lecture what are the different problems. This is the introductory part. In this lecture, we are discussing about the introductory part of the multiplexer and the demultiplexer. Demultiplexer, it is the opposite of the mux. See here, opposite means here we can say that mux means 4 is to 1, 8 is to 1, 16 is to 1. From many inputs, only one selected in the output. Many inputs are there and only one output. And with the help of select lines from the inputs, only one selected in the output. That is said to be multiplexer. But what about the demultiplexer? The demultiplexer is the combinational logic circuit that performs reverse operation of the multiplexer. Several output lines, one input line means here 1 is to 2 demux. Okay, like that. See here, again it works on the principle of that is select lines. If suppose only one input is there and there are four outputs lines are there, P0, P1, P2, P3. These are the output. If suppose select line 0 0, these are the select lines again. If suppose 0 0, then we can consider it as P0, it is the output. Then 0 1, P1, 1 1, P3. These are the output. Okay. The demultiplexer is the combinational circuit that perform reverse operation of multiplexer. Several output lines here, the output which are based on the select lines 2 is to 2, which is equal to 4 4 outputs are there, and only one input. It is to be considered for demux. Okay. Then what about the internal logic circuit for 1s to 4 demux? See here H0, S1, these are the here select lines. Consider is bar, S1 bar and S0 bar. Okay, the here bar which is to be considered S0 bar and S1 bar with the help of one of the inverter, not gate, so that and we consider four AND gate, mm, five four AND gate because S0 bar S1 bar P0, it is said to be the output here, so that here first AND, that is S0 bar S1 bar, and here we can consider it as third X. It is the input. Okay, this is the input applied to the multiplexer. So input is common in all, so that here we consider it as P0. Then what about the P1? That is A0 S1 bar, it is said to be X, it is said to be P1. Like that, here we can implement by using logic gates the design of the demux. Okay, then what about the see here? What explanation? S0 bar S1 bar means 0 0. P0 we can consider it as X. Here again S1 S0 bar 01 P1 here, which is equal to X. 10, that is S1 bar H0 10, then P2 S1 H0 11 P3, that is 4 outputs are there, P0 P1 P2 P3, and only one input, that is said to be X. Like that, we can implement here inputs, that is X and C. C which is equal to 1, uh, when 1 or 0, 0 0, 0 1, 1 0, 1 1 means here 0 0, this is one of the AND gate. X and C given, then F which is created as X. And when there is 1 1, then only F which is equal to X, so that it can be implemented. Keep in the mind multiplexer and demultiplexer, that is reverse of that mux. Here we consider 8 is to 1 mux, suppose 8 inputs, only one output. And when we consider the demux, 1 is to 8 demux, then only one input and 8 here possible outputs, and the output we can say here with the help of select lines. Select lines determines the what will be the output. Then third is the encoder. An encoder is a digital circuit. It is also one of the combinational circuit. It performs the inverse operation of the decoder. When we consider the encoder in the communication, then generally coding which is provided here, when we see the communication here block diagram for the PCM, then we can say encoder is there, so that encoder means for the here for the analog form, the coding it is to be provided, and that signal, analog signal, can be converted into digital one. As we know, there are different blocks, that is low pass filter, sampler, then quantizer, then encoder. Okay, then when we consider the samples with respect to time period, with respect to amplitude, we can say with respect to here time period, we can say when we divide the signal into uniform time, then we can say it is said to be sampler, and with the help of that time with amplitude, that is said to be quantizer. And after that, when we convert analog to digital signal, the encoder which is required for the quantization, encoding which is given means one of the signal can be converted into its coding format, so that in digital format we can convert analog information into digital one. Therefore, a decoder means reverse operation of the encoder. Okay, so an encoder has 2 raised to n input lines and n output lines. Okay, 2 raised to n means 2 raised to 2 if suppose inputs are considered, then outputs are 2. If suppose the encoder can be implemented with OR gate, whose inputs are determined directly from the truth table. See here, there are three outputs x, y, z, and the number of inputs can be calculated using 2 raised to that 3 outputs, which is equal to 8. Therefore, D0, D1, D2, D3, D4, D5, D6, D7, these 8 inputs are there. Here, if suppose D1, D0 which is equal to 1 and others are 0, 0, 0, means for the output is 0, 0, 0. For that D0 it is to be considered, it is to be selected. Then 001, this is the binary for 1. So D1 we can say in the output. Like that 010, it is the binary of 2. D2 is 1. Like that 111, it is 7. So that we can consider D7, it is high and others are low. Output x is equal to 1 when the input digit is 4, 5, 6, 7. See here, when we consider the x, here 4, 5, 6, 7. These are 1, 1, 1, 1. Therefore, in that 1, 1, this 4, 5, 6, 7. For y, we can consider d2. Here again 1, d2, d3. Here again 1, d6, d7. These are the output. For z, we can say 1, then 3, then here 5 and 7 for the z. Just like that, here see here, output x is equal to 1 when the input digital 4, 5, 6, 7. Output y is equal to 1 when the input digit 2, 3, 6, 7. Output z is equal to 1 when the input digit 1, 3, 5, 7. Like that, when we consider this by using the truth table, here simple truth table is there. XYZ 0101 possible combinations are 8, Y 00110011, X 00001111. These are possible combination when we consider the three variables XYZ. If suppose 000, D0, 001, D1, 010, D2, 011, D3, 100, D4, 010, 101, and then D5, 110, then 1, 111, then here 7. Like that, here we can consider x, y, z. X is D4 plus D5 plus D6, D7. Y is D2 plus D3 plus D6 plus D7. Z is D1, then D3, D5, D7. Like that, here it is selected in the output. Then by using this logic expression for the x, for the y, for the z, here we need to consider OR gate, that is first OR, second OR, and third OR. Therefore, three OR gates required, and the inputs are D0 to D7. 8 inputs are there, so that we consider D0, D1, D2, D3, D4, D5, D6, D7. These are the number of inputs. Here, Z which is equal to here D1, D3, D5, D7. D1 it is to be connected, D3, D5, D7 it is to be connected. Then Y, D2, D3, D6, D7, this is considered for the Y, and also X, that is D4, D5, D6, D7. These are the connection for the X. This is said to be here decoder design. Uh, when we consider encoder design for the combinational circuit. Okay, this is the encoder design. In this way, the number of inputs and outputs, the output depends on here. When we consider the four inputs, means two outputs are there. If we consider eight inputs, three outputs are there. If we consider 16 inputs, four outputs are there. So first of all, make a truth table, then find the logic expression, then implement using the logic gates. Okay, okay, student. Any problem? Any problem, students? Shivaji Pathak, Pumema, Vinit, Rohan, Aryaman, Ekta, Mayuresh. अरे बोला आहात का झोपलात? है क्या सब लोग?
यस सर।
समझ में आया शिवाजी?
हाँ सर।
Okay, multiplexer and demultiplexer and encoder. uh, Demultiplexer, here select lines is important part. Then demultiplexer also select lines. Multiplexer means many into one. Demux means here one into many. Okay, in this way we can consider the design for the multiplexer, demultiplexer. We will see in the next lecture the remaining part, a different problem based on the multiplexer and demultiplexer. Okay, thank you, student. Thank you. You can leave the meeting.